This section is on the method of pairwise comparisons. So far what we've looked at are plurality method, board account method, and plurality with elimination method. And one thing they have in common is that they all violate the Condorcet criterion. So what we're going to look at next is a method that does not do that. All right, and that is the pairwise comparison method. In this method, every candidate is matched head-to-head against every other candidate. So it's kind of like finding a Condorcet candidate when we were doing the plurality stuff. Each of these matchups is called a pairwise comparison. And a pairwise comparison between X and Y, so one candidate and another, every vote is assigned to either X or Y, the vote going to whichever of the two candidates is listed higher on the ballot. So we're looking at the columns who is listed above the other. So the winner will get 1 point, the loser gets 0 points, and in a tie, each get half a point. The winner in this election is the candidate with the most points after all the comparisons have been tabulated. And just note that ties can happen, and it's not a big deal. We'll just, if we need to, we can choose another method to have a tiebreaker. All right, here's our first example. We've got 10 matchups from 5 candidates, so all the possible combinations of pairings. And the first 2 are done for us. So notice that with the first one, if we match up A and B, A is above B here, is above B here, here, and that's it. So that adds up to 7. And then B is above A and all the rest. Okay, and that adds up to 15. So B's going to get 1 point. It's usually helpful to keep tally, so that's what we'll do maybe up here. Let's see, A, B, C, D, E. So B's going to get 1 whole point there. All right, the next one, A versus C. So A is above C in this column, and this column, and this column, and in this column. Okay, and that's going to add up to 16. And then C is above A and all the rest. So here, here, and here. And that's 6. So 16 to 6, A gets 1 point. So we're going to need to record that. So A gets 1 point. Okay. So now we're going to do the remaining 8. And it gets easier as you go along. You'll be able to count the stuff faster. So A versus D. So this time we're doing A versus D. So A is above D here. A is above D here. A is above D here. Here. All right, and that's it. So that's 8, or it's 12 plus 1 is 13. So that's going to be 13. Where D is above A here, here, and here. Okay? And that is going to be 7. Oops, I think that's 9, not 7. Yeah, 4 plus 4 plus 1. Okay. And so A is going to get the point there. All right, next we have A versus E. It looks like A is above E twice, 6 times, so 8 times. 12 times, 13 times, 14 times, 18 times. All right, so 18 times. The A is above E in the schedule, leaving E with only 4. So A wins that, so A gets the point. again, so A has 3 points. B versus C. B versus C, so B is above C 6 times, 4 times, so 10. That's it. So B has 10, therefore C has 12. So C's going to win that. We're going to give C a point. All right, next, B versus D. So B is on top of D 6 times, 4 times, that's 10, 11. All right, just 11. And then D would be the other 11. So here we have a tie. I'm going to give half a tally to each of those, so half a point. So, all right. So B now has 1.5. D has just 1/2 a point. B versus E. B is on top of E twice, 6 times, so 8. Plus 4 is 12. Another time, 13, 14. All right, 14 times. And I'm just reading the chart left to right. And B, and then E would be the other 6, or the other 8 times. So B wins. I'm going to give B an entire point there. All right, almost there. C versus D. C is on top of D 6 times. Plus 1 is 7. Plus 1 is 8. Plus 4 is 12. We have 12, and then we have 10. So C is the winner there. We're going to give C another point. All right, C versus E. C is on top of E twice, 6 times, so 8, 9, 10, and that's it. So 10, which would make this 12 for E, because we have 22 total votes. So E is the winner there. We're going to give E a point. And last one, D versus E. So D is on top of E 2 times, 6 times, so 8 times. Again, 4 more voters, so that's 12. Plus 1 is 13, 14, 18. So 18 times, leaving E with only 4 in that comparison. So D is the winner there. We're going to give D another point. So our total now, A has 3 points, B has 2.5, C has 2 points, D has 1.5, and E has 1 point. So our winner, using the pairwise method, is going to be candidate A. So what could possibly be wrong with this method? This is going to bring us to the independence of irrelevant alternatives criterion. So I know that's a mouthful. You can just call that the IIA criterion. If candidate X is a winner of an election and in a recount, one of the non-winning candidates is removed or added from the ballots, then X should still be a winner of the election. Okay, so if someone drops from the race or is added, the winner should still be the winner. So say we eliminate candidate C, who drops from the race, someone who didn't win anyway, from this election, and B is actually going to end up winning instead of A. I'm going to illustrate that here. So let's list out who we have now. So we don't have C anymore, so we have A versus B, A versus D, okay, and then we have A versus E, and we have B versus D, B versus E, and we have D versus E. Okay? And so let's try to do this a little more quickly this time. A to B, it looks like A leads B. A leads B only 7 times. So B would have to lead the other 15. So let's keep a tally over here. So A, B, So B would win that one. Okay, A and D. A is ahead of D in the chart 13 times, which would mean that D is ahead of the A in the chart the other 9 times. Or, no, the other 9 times. Okay, so A is the winner that time, so we're going to give a point to A. A versus E, so A is on top 18 of those times, E is on top only 4 of those times. So A is our winner. I'm going to give another whole point to A. B and D. So this one is still a tie because we get 11 and we get 11 for both of those. So we're going to award half a point to each of them. So it's half a tally, half a tally. All right, B and E. All right, B is going to get 14 of those, leaving E with 8. So B wins that one, getting another full point. And D, E. D is going to get 18 times where it's on top, and E will have the other 4. So D is the winner for that, and D is going to get 1 full point. And we are done counting them up. So now we'll look over to the left. Our total tally, A has 2 points, B with 2.5, D with 1.5, and E with 0 points. So like stated at the beginning of this slide, B is actually going to be the winner this time if we were to eliminate C from the race. Okay, so now I'm going to go off on a little tangent here and bring it back to the purpose of this section. This is called the sum of consecutive integers form. Well, we're going to get a formula out of this. So say somebody asks you, what is the sum of 1 plus 2 plus 3, all the numbers up to 99? Well, you could probably sit there and punch them in your calculator, but there's always a quicker way, right? So let's write it out as if we were going to do it. So 1 plus 2 plus 3 plus so on and so forth plus 99, okay? And that equals some sum that we don't know. There's a little trick that goes along with this. Why don't we list those numbers out again, but we'll order them backwards. So if we were to do 99 plus 98 plus 97 plus plus 1, that's going to equal the same sum. All right, it doesn't matter the order that you add them in as long as they're the same. The reason we did that is because now we can, sorry, I think I did something with the volume, my mistake. Okay, the reason we did that is now look at the columns. 1 plus 99, if I add it vertically, it's going to come out to be 100. 2 plus 98, that comes out to be 100. 397, that comes out to be 100. And it's the same all the way through until the end, so this 99 plus 1 is 100. So, all of that. And if we take those two S's together, we're going to have 2 of those sums. So how many of those 100s do we have now? Well, we have 99 of them. So 99 times 100, so that's 9,900. And we're going to set that equal to the 2S that we got over here on the right column. And if I want to solve for S, the sum, I can just divide by 2, divide by 2. And that sum is going to be 4,950. So the formula for this is going to end up being your L, the number of integers, times L plus 1, because, and I'm looking at this, right? So, or if we were to say this divided by 2, this is really what we're looking at. So 99 and 100 is more than 99, so L times L plus 1 divided by 2. That's the formula anytime you want to add up consecutive integers and see what they get to. Now this question is a little different. It is kind of related to what we just did, but by one minor detail. So now going back to our pairwise comparisons, sometimes in a problem you may have way more than 5 candidates running. You may have 20, and you don't really want to have to add up the numbers 1 through 20. You want an easy formula to plug that into. And this is going to be different because every time we pair someone up, we can't have any redos or anything like that. Like I can't have B versus C and then C versus B. It's the same pair up. So anyway, the formula for this one is going to be slightly different. It's going to be, it's going to be n, the number of candidates, times n minus 1, one less candidate, divided by 2. Okay, so for example, in an election between 5 candidates, there were 10 pairwise comparisons, and we'll show that here. So 5 times 5 minus 1, all divided by 2. So that's 5 times 4 divided by 2, and that is 20 divided by 2, so 10. Okay? How many comparisons will be needed for an election having 6? So I can do the same thing. 6 times 6 minus 1, all over 2. And that's going to be 6 times 5 divided by 2, so 30 divided by 2, which gives us 15. Also, you can just, if you have 6 candidates, we can just add up the numbers below 6. So 5 plus 4 plus 3 plus 2 plus 1 equals 15. So that works too, but again, if you have a really large number, you may want to use the formula instead. So this is going to be that formula when you want to know the amount of pairwise comparisons before you get started. So once again, here's that formula. So n candidates times one less amount of candidates, so n minus 1, and we're going to divide that by 2. It's a little similar to the sum of consecutive integers formula, but in that one, it's n plus 1 or L plus 1, whichever letter you're using. So just kind of keep in mind that difference and pay attention to the question that's being asked. So are you being asked to add up consecutive integers, or are you being asked to find the number of pairwise comparisons? They're slightly different. Another example here, using the pairwise comparisons method, who won the election? Okay, so we're going to make a list of all the pairings. So first of all, I just want to use that formula real quick. So I know this one's pretty easy because there's only 4 candidates, but let's work that out. So we have 4 times 4 minus 1. Oops, that's a little sloppy. 4 minus 1. All divided by 2. So that's 4 times 3 divided by 2, and that's going to be 6. So we should have 6 pairings here. So that first one is going to be, I'm going to spread this out because we're working with limited space here. So A versus B. The next one is going to be A versus C. And then we'll also have A versus D. And we will also have B versus C. We're going to have B versus D, and we'll have C versus D. All right, let's start. So again, just using the pairwise comparison method. So A versus B is, let's see, we have A is on top of B 3 times, 5 times in the 5 column, and in the 8 column. So that's going to add up to 16 for A, okay, and then 6 for B. So the total amount of votes here being 22 votes. So A wins that one. Next, A versus C. So A is on top of C 6, and then 3, then 5, so 14 times. Okay, and C is remaining votes 8 times, so A wins again. A versus D. A is going to be on top of D 13 times. D is on top of A only 9 of those votes. So once again, A is the winner. B versus C. This time I think B is on top of C 9 times. So C is on top of B 13 times. So C is the winner. B versus D. B is on top of D in the 5 column, and that's it. So 5 there, so that makes 17 times that D is on top of B. And then C is above D. We're doing CD now. C is above D in the 5 column and the 8 column, so 13, which makes 9 for D, so C wins there. So let's tally them up now. A with 3 wins, so 3 points. B, 0 points. C with 2 wins, so 2 points. And D with only 1 win, so 1 point. So our winner for this election is going to be candidate A. All right, just a few more examples to finish up this section. An election is held among 6 candidates. What is the total number of pairwise comparisons in this election? And I think we've already done this. So this is just 6 times 6 minus 1 all over 2. So that's going to be 6 times 5 is 30 over 2. Gets you 15, so 15 pairings. In a round-robin tennis tournament, every player plays against every other player, so pairwise comparison. If 24 players are entered in the tournament, how many matches will be played? And this is great if you ever are going to be doing a tennis tournament or any other kind of tournament with your friends. If you know this formula, you can figure out how many games need to be played. So 24 minus 1 times 24. Doesn't matter where I put the 24. I can put it on over here. I can put it over here. It doesn't really matter. And that's going to be all over 2. And we'll save you the time. That comes out to be 276, but you're welcome to check that. Okay, we've got 2 more after this. All right, so these are some consecutive integers problems. So a little different. Remember, the formula is different this time. You can go about it the whole long theory way we did several slides back, or you can just use the formula. Remember, it's L times L plus 1 over 2, or it can be N or X or whatever letter you want it to be. It doesn't really matter. So we're going to say 100. There's 100 integers here, and then there's 101 because 100 plus 1. That's going to end up being 2. And we're going to divide that by 2, and that's going to come out to be 5,050. All right, with the next one, you can't really use the same formula because these integers aren't actually consecutive. Okay, they skip. It's all the even integers up to 200. But let's do a little trick here. I notice all of them are even, so they are all multiples of 2. So if I just pulled out a GCF of 2, okay, greatest common factor, that would make all this 1 plus 2. So 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6, and then so on and so on. 2 times 99 is 198, and 2 times 100 is 200. Okay, and we just did this part in the last problem. We found out that this was 5,050. Okay, so really it's just going to come down to 2 times 5,050. And that should multiply out to 10,100.